So if we now zoom out from our solar system to our galaxy, you can get a sense then for how vast our whole galaxy is. Here's an artist's representation of what our galaxy looks like. We call it the Milky Way. We see it in our nighttime sky as a faint band of light that goes across the sky. If you could travel away out into space and then look back and look down on our Milky Way galaxy, it would look something roughly like this. From one side of it to the other, it's approximately 100,000 light years across. So if you could travel at the speed of light, you'd be able to fly around the Earth 7 times in 1 second. At the same speed, it would take you 100,000 years to go right across our galaxy. We are roughly about, see if I can represent this in a different color, from the galactic center to where the sun is roughly the sun is roughly in this spot. It's roughly where the sun is. The distance between us and the galactic center is around about 33,000 light years. So we're about 2/3 of the way out from the center of our galaxy. So we don't live in the center of our galactic city. We live in the suburbs of our galactic city. Now we live in a spiral galaxy, and this is a representation of that spiral galaxy. There are two main arms that come out of our galactic center. This one is called the Scutum Centaurus arm. Because you can see the region of the sky in the constellation of Scutum, the Shield, and Centaurus. The other major arm is called, it comes out from this side, is called the Perseus arm. And the sun lives in a little sliver of an arm in here called the Orion Spur. Okay, so that's roughly where we live within our galaxy, the Milky Way. If you zoom out even further than that, you'll find out that our galaxy is not alone. We are a part of a local group of galaxies. And astronomers have got a great imagination, so what they've done is they've called that local group the local group of galaxies. And here are the major members of it. So you've got the Milky Way. The nearest major companion to us is a galaxy called the Andromeda Galaxy. That's the largest two members of the local group of galaxies. We've got a couple of satellite galaxies of our own Milky Way. Those are called the Magellanic Clouds. They were first documented by the explorer Magellan traveling in the Pacific Ocean, so that's why they're named after him. The Large Magellanic Cloud, LMC, and the Small Magellanic Cloud, SMC. Now, in terms of the distances from the Milky Way to the Andromeda Galaxy, look at how far away that is in kilometers. It's a crazy distance. That means that in order to get to the Andromeda Galaxy, it would take you 2.2 million years to get to it at the speed of light. So you can see the Andromeda Galaxy in the fall sky, but when you're looking at it in the nighttime sky, you're looking at it as it was over 2 million years ago. So when you're looking out into space, you're actually looking back in time. It would take light to travel that distance between us and Andromeda, so we're actually seeing the past. The light that arrives today from the Andromeda Galaxy actually left the Andromeda Galaxy 2.2 million years ago. Okay, now if we zoom out even further than that, I've got a representation of space on a very, very large scale. What you're seeing here is a graph of space. This is a plot of known galaxies with respect to our own Milky Way galaxy. So each spot on this graph is equal to a galaxy. And what we've been able to do is work out how far away a lot of galaxies in space are. They've done a tremendous amount in actually measuring the distances to these objects and the direction in which you need to go in order to get them. I'm going to put you roughly where our own Milky Way galaxy is. The Milky Way is approximately there. Now you might not be able to see that dot, so I'm going to make it a little bit bigger. The Milky Way is roughly inside that red dot. Now to give you a sense for how small we are in terms of space, that's the position of the Milky Way. The actual dot there, to scale, that single dot is around about 17 million light years across. Now that'll give you some sort of sense then as to how small of a place we actually have in space. If you could travel at the speed of light, you could fly around the world 7 times in 1 second. At the same speed, it would take you 17 million years to travel across that single dot. So far, the furthest galaxies that we have detected and identified are more than 13,100 million light years away from us. So the farthest reaches of the objects that we can see in our universe, it would take you 13.1 billion years to get to them. And you could travel around the world 7 times in 1 second. Hopefully that'll give you some sort of idea as to how large the universe is in comparison to the things that we see on an everyday basis. So to recap then, to get a sense for exactly what we're talking about, we've tried to look at our place within time and also our place within space. And the numbers are crazy. They're really, really large. Like if you consider some of the distances that you personally have traveled, like for instance in terms of walking or running, I don't think I've walked in any one experience more than about 10 miles at a time. Anybody ever done a marathon? Like a marathon is only 26.2 miles would be the distance you should travel in a marathon. Now in terms of a bicycle, a bike, the most I've ever traveled in a bike at one go was about 100 miles. And that was quite an achievement. I was sore for a week after that. How far have you travelled on a bicycle? Or if you take into a car or a motorbike? I've lived in America for just over 10 years. And in that time frame, for 10 years, I put about 190,000 miles on my car. If you go out and have a look at your own car, how many miles is on the odometer of your car? Now, if you consider that it took me 10 years to drive that distance isn't even the distance to the moon. So, in 10 years in a car, and you haven't even covered the distance to the moon. It's pretty crazy. Or how far have you travelled on a plane? Like around the whole world. If you could fly around the world non-stop, you're only talking about 25,000 miles. It's not that far around the whole planet. But in terms of space, That's just crazy. Here we are in 2015, and the Voyager 1 space probe to date, it's traveling roughly at 3.5 astronomical units per year. That means you're talking about 50,000 years to get to the nearest star. In a spaceship. That'd be some journey, wouldn't it? Certainly wouldn't sign up for traveling to the stars in a spaceship at the moment, because all you'd be doing is signing up to dying in a spaceship. The very first radio transmission, so that's 1894. Marconi sent the very first radio transmissions. So that is only, well, let's do the math. So from that to 2015, that is only 6, so that's 121 years. Which means if you were to send out if it was a very, very powerful signal and could travel into space, it would so far only have covered 121 light years away from the Earth. Anybody outside of that distance would have no idea that we would exist. And when you consider our galaxy is 100,000 light years across, you get some sort of sense for your place within space.